Indeed. Gentlemen, so with that, we move on to the last session of the day, subjected around role of government and industry in R&D, innovation and energy efficient technologies. As the keynote address speaker, it gives me immense pleasure to invite Shri Rajesh Agarwal, Member Rolling Stock, Retired, Ministry of Railways, Government of India. Our eminent speakers, Mr. Kamal Tiwari, CEO and Director, Daiki Access India Private Limited. Mr. K. Vijay Kumar Gupta, CEO, Rapier LED Chip Indus Private Limited. Mr. Ashish Upadhyay, Director, Asia Pacific, Silas. Dr. Narinder Singh Jassal, Senior Principal Scientist, CSIR, CSIO. Mr. Rohit Kumar, Director, Elifo Biotech Private Limited. Dr. Ashish Mani, Professor, Innovation and Design Center, Amity University. Welcome, sir. All right, ladies and gentlemen, I request everyone to please settle down and keep your mobile phones on silent to avoid any disturbances. With that, I now invite our keynote address speaker, Shri Rajesh Agarwal, sir, to please deliver the address. Welcome, sir.
August members of the dais and ladies and gentlemen, I am thankful to SOCHM for having me here for this last session on the role of government and industry. And what are we aiming at? We are aiming at a Viksit Bharat, and we are aiming at modernization of railways. So as far as this is concerned, we have already had a galaxy of speakers. So many new things can be done, so many wonderful things can be done, and already so many wonderful things are being done. The government and the industry is definitely doing wonderful things. But I would like to come back to basics. We want a Viksit Bharat, and we want so many trillions of dollars of economy or whatever. How does it happen? Does it happen if we have all these new things happening? Or let us say we have got in this current session, so many new technologies also to talk about. We can have hydrogen trains, we can have hyperloops, we can have all kinds of very high speed and semi-high speed trains. So many new things are possible. But what is the basic that makes it a Viksit Bharat? So I'd like this august audience to look back and understand how the world transformed from being an agricultural economy to a manufacturing economy. Perhaps all of you would know what happened in the United States. You would know what happened in China. You'll know what happened in Japan. You'll know what happened in the UK. You'll know what happened in Germany. What is it that made them transform from an agricultural economy to a manufacturing economy? What made China what it is today? What made Japan what it is today? And then coming recently, Southeast Asia, till maybe 30 years ago, they were fishing villages, but they have transformed. And they have become hugely manufacturing economies. Perhaps nobody remembers South Korea before the Seoul Olympics. Nobody remembers Singapore before maybe 1965 was thereabouts. But then they became hugely manufacturing economies. And by manufacturing economies, what I mean is anywhere from 25 to 40% of the GDP has to be manufacturing. Even today, the economies of Southeast Asia, several of them, are sustaining, after becoming developed economies, after becoming Viksit economies, are sustaining between 25 and 30% of the GDP. So in India, we were looking at increasing the share of manufacturing from some 15% to 25%. It was about 18 to 20%, I think, in the 1980s. And that time the auto sector was zero. Today, with the auto sector there, we are at a lesser level. In the last 10 years, despite the auto sector having grown from maybe 2 to 3% to more than 7%, our manufacturing, which was supposed to have increased from 15 to 25%, has remained the same around 15, 16%. And if I remove auto, it has actually slid down. So I think the primary role of government and industry both is to first ensure that we are able to do manufacturing. If we are not able to do manufacturing, if we want to remain dalals, or we want to remain traders, or we want to become service providers, we can never become a Viksit economy. Nobody in the world has become a Viksit economy by remaining traders. There is no example where without being manufacturing, no country, there is no example of any country having developed or having become Viksit, which has not done manufacturing. But I'll come to the how also. So I think the first thing we need to understand is that that issue has to be addressed. And in the last 10 years, we have remained exactly where we are. And if auto is to be excluded, we have actually gone down. And there is no indication that's going worse. As far as employability is concerned, the number of engineers we are churning out every year, of course, it's declining by leaps and bounds. Today, even IIT engineers are going unemployed. Perhaps you are employing about 5 or 6 million engineers in the manufacturing industry, whereas the country is churning out more than 2 to 3 million every year. So I think this issue basically needs to be addressed. So I would like to say that in both government and industry, both need to do it. See, the British brought industry into this country and they brought a few machines. But all the high end they did in Britain. It only began to happen after India's independence that we started to do it in India. And the public sectors, etc., came into existence. But when we restricted our manufacturing to exactly what it was and what the British left us with, and maybe made it worse or thereabouts, it did not go beyond industry level 1 to industry level 2, where we go into production lines, to industry level 3, where we also integrate local area networks and computers, and now, of course, to industry level 4 and industry level 5. So the primary thing that we need to do both in government and industry is to start upgrading this manufacturing from industry level 1 to at least industry level 2 or industry level 3. Industry level 4 is also a low-hanging fruit. It's not difficult to attain. If government PSUs can do it, I'm sure the private sector can do it. So the basic thing that needs to be done both by government and industry is to see how we can revise our procedures and how we can revise our methods to be able to go for better, more efficient manufacturing. Let me give you an example. When I was part of the railways, I was heading a factory in Raebareli called the Modern Coach Factory, where we were expected to do about 200 coaches in a year. And within 2 years, we were able to increase it to 2,000 coaches. And perhaps it can even be increased to 5,000 coaches. It is only the processes that have to be brought into place. If it can be done in a government department, it can easily be done in industry. So, what is it that you need to think about? Let's say you're planning any system, be it in engineering, be it in construction, be it in manufacturing, be it. If you can do the same thing in less space, I can tell you for manufacturing that whatever work center you have with you, you should be able to look at doing the same thing in less than half the space. You should be able to start looking at how you can double or increase the production maybe 4 to 10 times. If modern coach factory can increase it by 10 times and perhaps look at increasing it by 25 times, then why is it that we cannot improve our production to go to that level? Earlier, when we had a lot of manual labor and processes were weak and we still were left with the legacy of the British, conversion costs were very high. So if you had a cost of material may be only 20 to 30%. The cost of the finished product was very high. But now with automation, now with mechanization, now with Industry 4.0, there are situations where the cost of material is your basic constraint. That is your A category to look at to reduce your prices. And if you can do the same with a higher outturn in lesser space, I think both the government and the industry need to start thinking in that direction. I think since time is short, I don't want to take too much time. I can discuss a lot about hydrogen trains and Hyperloop and a lot of things that the government. The only thing I'd like to emphasize is that I would like immediately, starting today, what is our problem in looking at robotics? Why do not we consider robo as a solution? It's so easily possible. It can do your manufacturing, it can do your inspection, it can do your data logging. I don't know why we don't have robots as the norm. Exclude the auto sector, which is dominated by multinationals. Robotics should be the order of the day. It's very simple. You can have it in your home also. Why can't we mechanize our welding? Why do we still do all kinds of welding, manually and have poor quality? It's very easily doable in multiple directions with multiple materials with much better quality and giving infinite life. There are a host of solutions. We have to start planning our activity in such a way that we minimize space, maximize outturn, thereby reducing our costs, and finally getting much better margins and much better profit. That is what I think will make India Viksit Bharat, and maybe modernization of railways, both for the government and industry, should be modernization of manufacturing in the railways. Because if we are going to still manufacture the same old way, even in India we will not be able to compete. China will send the material from China, and that will be far cheaper and better quality than what we can make over here at a higher price. So I'm, of course, free to discuss with you on the sidelines for very specific solutions for robotics, for your work centers, for your production lines, and it is purely on experience of what I have actually implemented. It's nothing to do with any profession or anything. It's basic practical examples and how we can actually, move ahead in this direction. Well, thank you, ladies and gentlemen, and of course, feel free to interact with me in the course of the session. Thank you.
Thank you, sir. Thank you, sir, for walking us through. With that, I now invite our next speaker, Mr. Kamal Tiwari, CEO and Director, Daiki Access India Private Limited, to please deliver the talk. Welcome, sir.
Yeah. Thank you. Good afternoon, ladies and gentlemen. And let me take you into a different viewpoint. So, like the chair of the session said, we have few keywords here. Viksit Bharat, which all of us are talking and dreaming about. Then we are also talking about the modernization of railways. So while we are talking about core technologies in railways, which have to be modernized, but we also spoke about or heard about modernization in user experience, about the overall approach of the railways. And another critical aspect is basically it has to be sustainable. It has to be sustained for over a period of time. And one of the key goal in railway is to become net zero by 2030. That is the stated goal. And what we do, basically, I represent a company called Daiki Access. We have a stall here, so we can maybe talk details there. It's a Japanese company, part of Daiki Group Japan, which is almost 30,000 crore group. And we make some very simple but robust and useful product called Jokaso, which is micro STP to treat wastewater generated at any facility, whether it is at a house or at a office or industry or any other place, including railway station, which can be treated. And after treatment, the water is safe to discharge to environment, or it can also be reutilized. And by doing that, by reusing water, wastewater at a local level, you can directly contribute to net zero, because extracting water, treating water, and transporting water, and then discharging wastewater all adds to energy consumption. So that can be reduced. So what I will do, instead of maybe running through the presentation, I'll take you through a video, and then we will just maybe see which is the important point. Just give me a minute. हो नहीं रहा, just help me out. हो नहीं रहा, मैंने वो स्लाइड में रन हो रहा है. हाँ वहाँ पे वीडियो उसको कर देते हैं अलग से. यहाँ से करते हैं. हाँ जी.
Welcome to Daiki Access Jokaso, the world's largest producer of sewage and wastewater treatment plants. Daiki Access Jokaso caters to both small and large wastewater treatment requirements. Jokaso utilizes globally acclaimed Japanese technology and a gravity flow system suitable for any environment, enabling the biological treatment of waste material. Utilizing gravity flow, the Jokaso unit ensures incessant water flow, continuously treating the wastewater, separating solid waste and liquid waste in the first chamber. The second chamber brings the waste material in contact with environmentally friendly anaerobic bacteria, decomposing the organic material. Special media allows the bacteria to thrive. The third chamber brings the waste material in contact with aerobic bacteria, completing the treatment process. This bacteria is supported with a small blower, redirecting any remaining solid waste back to the first chamber. The treated water is released to the environment through the fourth chamber, after disinfection using the chlorine device. The Jokaso unit is absolutely easy to install and can handle outflows of any scale, and is expandable. All you have to do is add new units to the existing system. From a simple home to factories, schools, and hospitals, Jokaso provides an effective means of treating wastewater, benefiting society at large. If you consider yourself concerned about making the world a greener place to live in, you definitely require a Jokaso unit for your home. The next big thing for a better world. Create a clean green space for you and your future generations to live in.
Daiki Access India has set up 2 factories under Make in India. A partner network of 30 companies and 800 plus projects across India to support the Indian market. Daiki Access is leading the way for water secure India, and we invite you to join us.
So under the innovation, one of the key point I would like to mention, in constraint of time, I would not run through the whole presentation, is basically the simplicity. When you make technology which is going to be used at a large scale we are considering customer like railways, which is spread across the country, then the technology has to be simpler so that it is able to, one, you are able to deploy it at the local level, you are able to work with the available skill set available at different settings and places. So that is all is the core point of Jocaso, which could be useful. I would be very happy to take you through the details. Thank you so much. Yeah.
Thank you, sir. With that, I would now like to invite our next speaker, Mr. K. Vijay Kumar Gupta, CEO, Rapier LED Chip Industries Private Limited. Welcome, sir.
Good afternoon, friends. I'm going to present a very revolutionary new technology to keep your indoors sterile on a continuous basis, on real-time basis, right? And then, of course, it's most important that all our coaches, which are normally we are gradually moving to all AC coaches, be it Garib Rath or similar ones. I think we are now looking at how to keep the whole thing sterile, so how to take care of health security of the rail passengers. So one is, even this was discussed at the highest level, both at Niti Aayog and Ministry of Health. At that time, they were trying to convert some of the coaches into isolation wards. So it was agreed that AC coaches could not be suitable in view of risk of viral circulation through AC ducting. And there is also need for cross circulation of air through open windows and need of higher ambient temperature to fight the virus. In the case of the low temperature inside the coaches because of AC, again that could be a plus point for the growth of the virus as well as this thing. So we need a completely different technology to keep the AC coaches free. So it was, are we finished with the pandemic? No, more than 100 immunologists said that we are going to continue with new variants of this dreaded disease, coronavirus and other things, and we are already hearing quite a lot of them today. So however hard we try, we are going to be under constant attack from such viruses through evolving mutant things. So we need a technology that can fight all microorganisms, which can kill every type of microorganism to a high certain degree of certainty, and also without causing harm to the living beings. We are very well aware of UV technology, ultraviolet light. But when you are putting that light on, you have to be out of the room. It has to be an empty room that you can sterilize. Similarly, when you are putting it through fogging or many other chemical methods, again, it has to be, you can't enter the room for half an hour after the fogging is done. Similarly, there is no way of any kind of mopping or thing, which is all, it leaves incomplete, right? So we need a continuous disinfection method, as well as, which has almost low maintenance, right? So we have a solution here, sustainable preventive healthcare with Rapier non-UV lights. This is a non-UV light. That means the light within the visible region, that is violet, indigo, blue, green, yellow, orange, red. We are talking about this region. Within the visible region, there is a wavelength which is very closer to the blue and violet, which also kills every kind of bacteria. It has been documented for the last 20 years on every known pathogen known to the mankind. And then of recently, when the pandemic hit us, we got it tested on the coronavirus also through CCMB, and we found excellent results there, so very positive results. So we have developed a safe, hygienic environment has become paramount. Rapier, a pioneer in non-UV disinfection technology, offers groundbreaking solution that ensures continuous protection without harmful UV radiation. Let's explore how it can contribute to sustainable and preventive. It is a preventive health care. So every home, every college, now right now we are all here, gathered here. Some of us could be breathing out dormant infection within themselves. They are immune to that, but the guy next to you could be like that. In the schools, we find that once a respiratory disease start, then it starts to every school children, and from there it comes to a family, and from one family member it goes to all the family members, and when the working person goes to the office, again it gets spread to the whole office. So that's how we see these endemics, right? So we are a group of companies started around 60 years ago, 1987, manufacturing lighting at that time, and then since 35 years manufacturing LEDs. So we have come up with a solution to tackle various bacteria and virus using LED of selected spectral characteristics. So it is the first non-UV disinfection. We have a patent where we combine, we are manufacturers of LED chips. We are the only company in India manufacturing semiconductor chips. And this we have been doing since last 35 years. I am an engineer, scientist, gold medalist from Indian Institute of Science, Bangalore, and made my LED part of my PE project 40 years ago, and worked as a scientist here in CEL to develop LEDs under DST project. So since then, I've been only manufacturing LEDs and LEDs that's all. So the non-UV LEDs contain antibacterial blue rays, which is the violet end of the light, which have power to kill microbials and is very well tested. I'll be showing you the certificates in the later slides. So they have been even tested on coronavirus, as I said. And this, because this wavelength is not there in incandescent bulb, it's not there in tube light, it's not there in CFL, it's not there in LED lights also. Because we make the chip ourselves, we have incorporated this particular spectrum wavelength into the chip, and we have got a patent for that. And this, because it's a chip, it can be used in every lighting source. You have a tube light, you have 100 chips inside. You have a downlight of 18 watt, it's got 200 chips inside. So you have got a 2x2 panel light, again you have got more than 400 chips inside. So all these can be converted into partly illuminating and partly antibacterial, right? So again, I think lots of time we can do that. So we can, the use of these Rapier lights within the coach, it reduces the chance of cross-infection. We are worried about cross-infections basically. It starts from one person to another through aerosol, airborne diseases. But it also removes every kind of bacteria from the room. We all heard about hospital-acquired infections. During pandemic, corona, we heard about black fungus. It's a fungus which is right now available here and is classified as harmless. But when your immunity is down, when you are under treatment, it enters your nose, it eats away your eyes, it eats away your brain. So such things are not able to be cleaned by the normal cleaning process in anywhere. And you know the workers are generally arbitrary, they cannot clean all that. So this light in the room, if you convert all the lights in the ICU or hospital completely, they can continuously on real-time basis start removing the bacteria from the air. And this clean air, which is under this light, it moves around, goes under your sofa, behind your bed, behind your table, and removes the germs from there. They come into it and they get exposed and they get killed. So ultimately, in a day or two, every crevice in your home or office or school will get cleaned of any bacteria. So it's a wonderful technology which is self-cleaning, this thing. And basically, in railways is what we want to suggest to you. And it can be used for offices, as I said, it's required for its hospital, hotels, restaurants, and cafeteria. And for schools and colleges, very much important, right? And these are the certifications. At CCMB, you can see that within 15 minutes, 40% of the reduction of coronavirus has been observed. We normally assume that these are indestructible, viruses are indestructible. But here you can see the excellent action within 15 minutes, the blue line on the second line. And then within 60 minutes, the fifth one, it's 90% within 60 minutes, 95%. And these are the ones where normal atmospheric pathogen has been reduced to 80% within 1 hour of lighting with one light. And of course, we are going to use many more lights depending on the traffic people, like air conditioning. We need more higher wattage of air conditioning when more people are there. And you want to remove things faster. You want to cool the room faster. You will use higher power of air conditioning. Similar way, if you have a lot of traffic walking through, you can use these lights completely in whatever way. And the second one is the test by MS University Baroda. They have tested the whole spectrum of this, and then they found that there was no UVA, no UVB, no UVC, no infrared. It's purely visible light. And visible light, we know mankind has been using for millions of years, and we are happy with that. So it's through general technical knowledge, it's harmless. And also, the proof of it pudding is in eating. So we gave it to a dermatologist organization, it's Oliva. It's again a national level chain of, they've got 158 all UK certified dermatologists. First we showed them that within 1 hour how the bacteria has come down in the room. And then, then they have used it for 4 months, and they found that all their staff who are constantly under that light, they have no complaints whatsoever, and they gave us a certificate of that. That's what you have seen here. And the ICMR has recommended, again, this Sonepi Suhaga, that it can be used in all public places, public transport system, hospitals. So it's well proven. University of New South Wales, Australia have done it on the live corona there. And we have got a patent recently awarded very, very short time. So we are delivering sterility through lighting, and it's a wonderful, and it's a zero consumable, zero maintenance. You fit and forget it, and no extra installation required. You just remove your normal light and put this back, and forget it for 5 years, 6 years, 10 years. So no recurring cost, no power also, because the power is already being used by your water power you're supplying to your lighting, same power it uses. It's a wonderful solution from any angle, whatever you see, right? And it's continuous, and you're always secure. So let us be preventive, let us prevent disease spreading, and I hope to see that these lights become a mainstream lighting for whole India anytime. Thank you so much.
Thank you, Mr. Gupta. Thank you, Mr. Gupta. We'll take up the questions towards the networking lunch. With that, I invite Mr. Ashish Upadhyay, Director, Asia Pacific. Silas, welcome, sir.
Hello, good afternoon, everyone. I'm representing a company called as Silas. We are in rail cybersecurity space. From the morning, we have been hearing about safety and security, right? And in today's session, I will be addressing this kind of unaddressed topic, cybersecurity in rail. So when we look at railways, railways is part of critical infrastructure. I think many people are aware about this specific word called as critical infrastructure, but when we speak about the railway systems comes under a specific category called as safety critical infrastructure information systems, CII, okay? So when we look at CII networks, CII is these networks which are used in very specific environments like nuclear power plant. Let's speak about Industry 4.0, okay, oil and gas refineries. These are closed loop networks, and the security needs of these closed loop networks are different. What we do as Silas is an Israeli cybersecurity company, and we are the category leader in rail cybersecurity. We only do security for rail, and it's a different category altogether because rail is a super complex environment. Silas has been founded in Israel, but we work in a global scale, and we have impressive presence in different parts of the world. So looking at today's agenda, and we are running short of time, I will be speaking about only specific topics which could be interesting for you, because cybersecurity in rail is sometimes not well addressed and not well thought of before designing any new system. When we look at this topic called as Viksit Bharat, Viksit Bharat is where we, from the morning we heard about we are buying new trains, we are adding, number of kilometers of track each and every day. We are building a complex infrastructure, right? We are buying new locomotives or building new locomotives in India. But when we look at the safety component here, safety component is well addressed because there are various standards and compliance related to safety. For cybersecurity, the standards started coming out in last 4 or 5 years. And when we look at cybersecurity, cybersecurity is a very complex environment, and there are a lot of topics which are linked to that, which are linked to cybersecurity, like AI, quantum computing, and different regulations as well. So these are some of the standards. I will not be focusing on these standards in this part. When we look at in last 10-15 years, what has happened? We have there's a lot of digitalization that has happened. When we speak about this word called as modernization, modernization word is linked to digitalization as well, because we have been starting incorporating a lot of advanced technologies like predictive maintenance technologies, asset management tools, and we have been using we have unattended train operations as well, grade of automation 4. Our Honorable Prime Minister, I remember in 2019, Delhi Metro Line 8 was one of the line where there was unattended train operations started. Similarly, when we look at Indian Railways, we are speaking about Kavach systems, right? New Vande Bharat trains where we are seeing, trains are connected over Ethernet networks, and very high-end TCMS systems are getting deployed, which is train control and management systems. But when we look at these connected systems, the biggest risk is the cyber threats. And today we know that we have nice neighbors, and due to the current geopolitical situation, it is not easy to kind of work in a, to work in an environment where there are safety critical networks linked to the passenger safety. And there are a lot of attacks which have started happening in the railway environment. In last 4-5 years, I've seen there is a rise in 173% attacks year on year, and these attacks have become much more sophisticated every year. So when we look at railways, we always speak about safety critical systems, SIL4 systems, right? But the sad part about about SIL4 systems these are very easy to be compromised, because when these systems were designed, security was not thought of. So the SIL4 system can have a 0 security level, and this is something that many of the OEMs and rail authorities ignores, because this subject is not well discussed. And when we look at safety, there are specific safety standards, there are specific safety I would say processes which basically help us. If there is any failure that happens, what will happen is trains will stop. Okay, we will move into the fail-safe mechanism. But when we look at cyber security is, cyber incident or cyber attack is intentional attack. It is something external, and it can lead to, these external intrusion can lead to a different complex situation altogether. And people sometimes get confused with IT security and OT security. Let me explain you a little bit this specific part. IT is information technology, which I think a lot of companies are working here. A lot of companies provide security solution. OT is operational technology, which is the safety critical part of the network, like signaling systems, SCADA, rolling stock networks. And this is something which is not, people don't speak about this topic. And I told you, like, it is very difficult to secure a complex environment, because railway is a mix of different systems altogether. We have multiple rolling stocks coming from different vendors.
I think we'll have to be quick now.
Yeah, sure. I'll be taking one or 2 minutes, and I will be closing that. So when we look at railways is a complex environment. Different OEMs provide different systems, and understanding different technologies, different protocols is again not easy. And securing these protocols and these particular systems again is not easy, because we have legacy systems working in railways and we are deploying new systems as well. So we need to see how we can kind of address this. And this is the reason a lot of standards have been started coming into the railway environment. India has also adopted some of these international standards. Ministry of Railways has issued some guidelines, but we are really very far to adopt security into the railway environment. So when we look at cyber security, there is a framework which is identify, protect, detect, respond, and recover. I will skip all this framework right now because of the short of time, but it is important that we kind of look at this particular subject and adopt a right security framework while bringing new systems on board. Thank you so much.
Thank you, Mr. Upadhyay.
Thank you, Mr. Upadhyay, for the quick walkthrough. With that, we move on to our next speaker, Dr. Narinder Singh Jassal, Senior Principal Scientist, CSIR, CSIO.
So may I humbly request the speakers to restrict to 3 minutes, please?
Sure, sir, sure.
Thank you. Thank you.
Thank you so much. So first of all, I thankful to ASSOCHAM to just organize this national conference on Mod Rail Viva. And I am representing CSIR, that is Council of Scientific and Industrial Research. So I will not go much detail in this presentation. Basically, that is not possible to just conclude in 3 minutes. So CSIR is one biggest R&D organization of India, having 37 R&D laboratories. And I am representing my CSIR, Central Scientific Instrument Organization, CSIO Chandigarh. And we are doing a lot of research project in biomedical, in space, that is strategic sector, in seismic, public safety, sensor technologies like that. And here we have the lot of industry, and I request with all industry, if you need connectivity with the CSIO, so you can contact with us. And we already transfer few technologies to Indian Railways. One is one UVC air inspection system to Sidwal, Amit Engineers, Magneto, like that. And we are also just transfer our one technology to Delhi Metro also, that is earthquake warning system. So we can also implement that in our Indian Railway. And we also have Dr. Ramesh Tiwari, Senior Principal Scientist with us, and he also have one technologies that can help us in the health monitoring of our this rail, this track, our wheel wagons, and all other structures that is utilized in the this rail coaches. And we also have one scheme that is promoting innovation. And if you have any innovative idea in your mind and you wish to convert that idea into the product, we are this one PRISM scheme that is governed by DSIR. And CSIR is one center that is just representing northern part of our country. And you can get the grant of rupees 20 lakh to convert that idea into the reality. And after that, you can also launch your startup to get again grant of rupees 50 lakh. So you can imagine government is providing rupees 70 lakh for idea to industry. So Dr. Umesh and myself is available at the lunch. If you have any query regarding this PRISM scheme, regarding CSIO, CSIR connectivity, and we also have one Industries Training Center that is just like a polytechnic. You can also talk with us for this skill development. So we are happy to connect with industry and Indian Railways. Thank you very much.
I'm thankful to you.
That was really quick, Dr. Singh. With that, I move on to the next speaker, Mr. Rohit Kumar, Director, L4 Biotech Private Limited.
Good afternoon, everyone. My name is Rohit Kumar, and I am representing a company called Elifo Biotech. We are basically into biotoilets, and we are the largest inoculum provider to Indian Railways today. So I will be talking about what is happening currently in water treatment industry. Daiichi Access is already one of the key players today in the industry, apart from DRDO and various other technologies. And what lessons railway can try and learn out of various developments that are happening. Because railway treatment systems are quite specific. Their environment is quite specific. You have a treatment system which will be running on the rails at 80, 90, 100 kilometers speed. It will stopping frequently, so that environment is different. So we, as a technology developer, do not really get to experience that kind of place. So if we get that opportunity, we can collaborate with the railways. We can help railways in going a step beyond what it has already been doing, and which is a very commendable job in terms of keeping our stations clean today. Everybody knows that 10 years ago, our plate pumps were very dirty with whatever is happening on the trains. So we don't have sufficient time, so I will try to skip some of these slides. So basically, what is a human waste? Human waste is essentially water with some part of organic component, nitrogen, phosphorus, potassium, traces of them. However, when we analyze them, we basically focus on what is the BOD, what is the COD, what are E. coli, total nitrogen, etc. present. So all our parameters, which is set out by pollution control boards or NGT, are around these. So currently we have a system for railway which does a fairly good job, but it is not able, it will not be able to meet the kind of standards NGT has set today. So if you look at the technology in the wastewater treatment systems, there are anaerobic technologies, there are aerobic technologies, and anaerobic nothing but putting the waste into an air-free environment, so there is no air, no oxygen basically. The aerobic is where you pump in a lot of oxygen to treat these fecal matter. And then there is a nature-based, where you let plants to take care of, or you build up wetlands and all. Then these are the three. Then you combine anaerobic, aerobic together, like Jakasu is doing. Then there is aerobic combined with some kind of a membrane system. Then you have anaerobic with membrane. Now the latest developments are around thermal. So there are systems where solids are taken out from the water, it's thermally treated, and then again released. And then the latest one probably would be the electrolysis system developed by Caltech University, which is ECR, electrochemical reactor. But these systems are pretty expensive. So I'll take you through some of these packaged wastewater treatment systems currently existing. Of course, first one is Jakasu. We've already seen it. Then there is a company called SCG Chemicals, who is based out of Thailand. They have come up with Zyklon Cube, but we still have to see a working. They have actually installed 3-4 systems in India, which could not achieve the kind of results we were looking for. Then there is another company from China, Ecosan. Their system is based on Caltech's technology, which is ECR technology, electrochemical reactor technology, which is kind of a little expensive to operate, but currently some tests are going on this system. This we ran for a year. We ran a prototype of this system developed by Duke University called Reclaimer. There's a long way to go in this system as well. This is something, a technology of future, which is being currently developed by Georgia Institute of Technology. And there's actually a plethora of institutions which are collaborating with Georgia Tech to come up with a system which can be used to treat waste at home with your seat. So they have imagined that every house will have a back-end treatment system, just like our AC outdoor unit, and the front-end front-end system, which will be more like our AC in our each
Mr.
room.
Rohit,
So,
I think if you can be a little quick, please.
so this is what we have been developing. We have already patented one process in this. We are in a process of patenting another 2, and we expect to take another 5 to 7 design patents. So in all, there will be around 10 patents in this technology. If you look at these bottles, on the left-hand side of the bottle is a very dirty water which is going in. On the right-hand side, we have the output water. We are still trying to put it in an IoT system. So the last slide. So basically, what we are trying to see is that we already have a very good system in railways, but given the requirement of NGT, we might have to upgrade it. There are plenty of new technologies and new efforts are happening around it. Maybe railway can look at, some of us can collaborate with us, and maybe we can set up some of these systems. They can test it. If they work, they can upgrade their system, because there's a lot of modification that will be required specific for railway systems. Thank you.
Thank you, Mr. Rohit. With that, I invite our next speaker, Dr. Ashish Mani, Professor, Innovation and Design Center, MIT University. Welcome, sir.
Thank you very much. And I am fully aware that I am the only one between you and your lunch. Right? But this conference is very important. And railways is very crucial for development of India, right? It's a behemoth. It transports around 8.5 billion passengers and 1.2 billion tons of freight. Now, if we want to develop India, we need to modernize Indian railways. And as during the day, a lot of deliberations have gone, which showcased that a lot needs to be done. And if you see, even digitalization of Indian railways is not up to the mark, as it is the case in many other industries. So we are very far from what we call as Industry 4.0. Basic digitalization technologies are also not in place. There are 2 sets of technologies, one which are very capital intensive. So let's say if I want to improve on energy efficiency, and you will be surprised to know that 20,000 crore is the budget for Indian Railways for electricity supply only, right? So if we move to more advanced technologies like hyperloops or maglev, we can reduce this budget almost by half. That means we can have a saving of 10,000 crores. And these technologies, we all are aware that they are in very nascent stage. They require huge R&D funding, and even post R&D, their installation costs are exorbitant. So very targeted R&D can be done to reduce the cost, improve the reliabilities. But there are certain other set of emerging technologies, which are what you can call is low-hanging fruit. For example, integrating artificial intelligence or Internet of Things to improve the services of railways which it offers to its customers, both for freight and passengers. And one such model which Government of India is actively pursuing is that of open innovation model. Railways, as I have figured out, is moving towards it. Like they have 2 problem statements in Smart India Hackathon. One is on navigation, that means railway station navigation for passengers. The other one is Rail Madad. But as we have discovered throughout the deliberations, that there are many problems that can be given to our young minds, our students, in form of hackathons, so that they can brainstorm, ideate, and that way railway is going to have multiple solutions for each of their problems, which they can choose from and implement. So in a nutshell, railways, if we want to modernize with innovation rather than aping or copying solutions from West or China, right? We need to follow the open innovation model, build an ecosystem where we include all our young minds and facilitate them so that they can be productive and they can modernize Indian railways to suit our conditions. Thank you very much.
Thank you, Mr. Mani, for beautifully setting the context. Ladies and gentlemen, let's have a huge round of applause for our speakers. Because of paucity of time, we might not be able to take up any questions. We can take the questions during the networking lunch. I would request our panel to please step up for a group photograph. Thank you, sir. So, ladies and gentlemen, as every good thing comes to an end, so has this eminent and prestigious conference of modernization of railways for Viksit Bharat. On behalf of the entire ASSOCHAM India committee, it's my pleasure and privilege to thank each and every one of you for taking out time. Before closure, I would request everyone to please proceed towards the lunch area for a networking lunch. And we'll see you soon next time. Thank you.